What's going on, everyone? Hope you guys have a great day so far. It's Ben, and today we're going to be covering how to compute derivatives using the limit definition. I'm going to be showing you the formula, how to use the formula, and what the answer means and how we can interpret it. So let's get straight into it. So right here is the definition of a derivative, the limit definition of the derivative. And so whenever we need to find the derivative of a function, we're going to go ahead and use this formula. There's reasoning behind where there's a whole proof of where this formula comes from, but for a Calculus 1 student, that's not super important, and your professor could probably explain that way better than I can. But I'm going to be showing you a few examples on how to actually use this formula so you can so it can help you on your homework, on your tests. Because I know when I was in Calculus 1, I struggled a lot with this and I didn't really know what to do, or it was just all this confusing notation just really threw me off. But I'm going to be going step by step and very slow so you guys can really pick it up and how to use it. So let's get right into the first example. So for our first example, we're going to be looking at the function 3x minus 8, and we're going to be going ahead and trying to find out what the derivative of this function is using the limit definition. And so if you guys haven't seen this notation right here, this f of x with a little apostrophe or little dash is called f prime, or just the first derivative. So that's what we're going to be trying to find. So right off the bat, looking at our equation here, we're going to be taking a limit, right? And on the top part right here, we have an f of x plus h minus f of x. Well, we already know what our f of x is, right? We could already plug this into here, which is fine, but we don't know exactly what f of x plus h is. So we need to go ahead and just figure that out. And all we have to do is wherever you see an x in your function, you need to plug in x plus h. So here, for our original function, our input is just x, meaning we just plug in whatever value of x into here. But for our new function, f of x plus h, wherever we see an x, we need to just squeeze in an x plus h. And this is what that looks like. So we have the 3 still, but then I'm going to do a parenthesis, x plus h, like that. And so instead of x, we plug in x plus h. And we're going to go ahead and attach the 8 at the end because there's no x's on the 8. So we can't do anything. It doesn't change. So now we have everything we need for our formula. We have our f of x plus h and our f of x. So let's go down here now and start solving it. So we have our limit as h goes to 0, and let's plug in what we have. So we need to plug in our x plus h, which is right here. So I'm going to go ahead and do 3 parenthesis x plus h minus 8. And then I'm going to do minus, because there's a minus right here, right? Minus our entire function. This is very important for you guys to take note of. When I plug in my function, I'm going to go ahead and plug it in, but I'm going to use parentheses here because that we need to pay attention to our signs. Our signs will throw us off if we don't pay attention. Because notice that now that we have parentheses, we have to distribute this negative in, which will change our answer. So now this is what we have, right? This is our whole thing right here. That is our f of x plus h, and this is our f of x all over h. Nothing changes with the bottom yet. So now we can't really cancel anything here yet. So what I'm going to do, I'm going to start distributing some stuff, opening up the parentheses, and maybe we can start canceling some stuff. Because we can't take the limit yet, right? We can't take the limit because if we were to do direct substitution and plug in the 0, we'd get division by 0, which we cannot have. So we can't take the limit yet until we do some simplifying. Maybe our goal is to end up getting rid of that h, so we can take the limit and find out what our derivative is. So going ahead and foiling everything here, we can foil this 3x, and then we'll foil this 3 to get to the x and the h. So we have to continue right the limit. So here we get 3 times x, which is 3x. Then we get 3 times h, and we still have that remaining 8 left over. And then here, we need to distribute this minus, right? So we get negative 3x, distribute the negative to the 8, negative 8. We should get a positive 8, right? Because two negatives equals a positive. And we still have an h on the bottom. So now we've distributed everything, and hopefully we can cancel some stuff. So if we look closely, we have a 3x. We also have a negative 3x. So 3x minus 3x is 0. So those go away. And look, we have a negative 8. We have a plus 8, which is perfect. We cancel those out as well. So rewriting our limit, now we have 3h over h, which is nice. And you can notice that if we were to plug in our limit, our 0, we still get division by 0. We'd have 3 times 0 divided by 0. So all we need to do now is just notice we have a common term on the top. We have the same term on the bottom. So we can go ahead and cancel these out, right? And then all we're left with is just limit as h approaches 0 of just 3. And notice there's no more h's, right? There's no h. It's just a constant. It's just a 3. So we can't take this limit anymore, basically. So we can go ahead and just drop that off. And we're just left with a 3. So on to the next example. We're going to be trying to find the derivative of 2x squared plus 6x. And I wrote the formula right here so we can keep this in our head and make sure we know what our formula is, where to plug everything in. So remember, our first step of the last example was that we need to find what this f of x plus h is, right? So what we did, we just looked at, we got our function, and wherever we see an x, we plug in an x plus h. So here we're gonna have 2, and instead of x, right, we're gonna do x plus h, and we have that squared. So this whole thing is gonna end up being squared. Now, with this 6x, we do have an x there, so we need to go ahead and plug in x plus h where we see an x, like that. And that's what's gonna go in here. So, but before we plug that in, I think it's a better idea to expand this on the side so it's not so clumpy on the formula. So, so if we go ahead and try to expand this, open some parentheses, it'll look cleaner. So when we plug it in there, we can start canceling everything out. So with this, x plus h squared, right? X plus h squared is going to look like this, right? And so we can go ahead and just FOIL this right away and see what we get. So we get x squared. So I'm going to keep this 2 on the outside. We're going to get x squared, and we're going to FOIL this over here. We're going to get xh. Here we're going to get hx, and then we're going to get plus h squared. And there we go. And then we can go ahead and just see we have a common term here. xh, xhx. Multiplication goes both ways. So x times h is the same thing as h times x. So we can actually write this as a 2xh, since we have 2 of them. These are the same things. We're adding them, so we have 2 now. So now all we need to do is just distribute this 2 into each of the terms. So we should be left with 2x squared. And then we're FOILing this into this middle term right here, sorry. So we're going to get plus 4xh. And then this 2 to the last one, we're going to get 2h squared. And then bringing this down over here, because we haven't done anything yet, all we need to do is just FOIL this 6. So we should get plus 6x and then plus 6h. There we go. And look, we don't really have any common terms here. This is an x squared, this is xh, h squared, x, h. Not any common terms here. So we can't really simplify anything yet. So now, all we need to do is plug this whole thing up into this part right here of the equation formula. So let's go ahead and move over here. So we need the limit as h goes to 0 of this whole thing that we got. So we're going to plug in 2x squared plus 4xh plus 2h squared plus 6x plus 6h. So these are some bad looking 6's. So, and then now we have this minus our function, our original function, which was just 2x squared plus 6h. Plus 6x, sorry. and this is all over h. And so now we can go ahead and just distribute that negative in. And I don't want to rewrite all this, right, because that might take a while. We can go ahead and just get rid of those parentheses, and we can just distribute this negative in, right? So we distributed the negative here to the 2x squared, and then negative is also going to distribute to that 6x. So that's just going to turn to a negative, right? Oh, sorry, that's going to turn to a negative as well. Sorry. This is negative. So now look, we have a 2x squared minus 2x squared. Those can cancel. Now we have a 6x minus 6x. Those can cancel as well. So now, rewriting our limit with our remaining terms, the limit as h goes to 0 of just 4xh plus 2h squared plus 6h all over h. So now, look, we still can take our limit because if we were to plug in h, that means 0 into all of our h's, it would still be undefined. We'd have division by 0. So, something that we should always look out for is common factors. Look, on our numerator, we have an h. Here we also have an h, right? H squared is just h times h. So we do have just an h that we can maybe factor out. And here we also have an h. So, since we have a common term of h in each, we have a common h in each term, we can go ahead and factor that out. We know how to factor some stuff out from our algebra, right? So taking out an h from each term means rewriting it outside of the parenthesis, but now we need to divide each term by h. So 4x h divided by h is just going to be 4x. And then we have 2h squared divided by h means we're going to take out an h. So we should just be left with 2h. And then here, taking out an h will just leave us with a plus 6. And rewrite our denominator. And we know we factored it right. If we were to FOIL this again, we'd get the same thing we had earlier. 4 times 4x, h times 4x, 4xh, h times 2h, 2h squared, h times 6, 6h. So we factored it properly. And now look, we have an h in the numerator being multiplied, and we also have an h on here. Meaning, we can go ahead and cancel these out. We can only cancel when there's multiplication going on here. If it was h plus 4x, we could not cancel it. But since we factored it out, this turns to multiplication to everything, right? Because we're foiling it. So that means the h's can cancel. Now, rewriting what we have the limit as h goes to 0 of our remaining terms, 4x plus 2h plus 6. And now, look, we don't have a fraction. If we plug in h, 0 for h, we won't get anything undefined. Meaning now we can apply direct substitution. So plugging in 0 for all the h's, we only have one h. So we should just get 4x plus 2 times 0 plus 6, which is just 4x plus 6. And this is our answer. Boom. This is our f prime. So if we were to draw this function really quickly, it would look something like this, a parabola. It's like this. And so what this is telling us that the slope at any point on our function, on our parabola, any point we choose, the slope at that one point will be 4x plus 6. And so, right, 4x plus 6. So if we wanted a point, if we chose this x point right here, 0, we plug that into here. That means the slope of the tangent line, or the slope at this exact point right here, the slope of that line, tangent line, the slope is 6. That's what this is telling us. We could choose any other x point on this function. We were to plug it into this derivative, right, our f prime that we found. That would tell us the slope at that exact point, which is very helpful. So this was a little bit more of a tricky problem. And so for our next example, we have the function x over x plus 1. And something that you're going to notice is that rational functions are a little bit ugly and a little bit complicated to work with, especially when we're taking limits, right? When we have fractions, we're going to have to add an x plus h to each of these terms. Like, it's not going to look too nice, but it's something that we can work around and we can figure out how to solve it. So let's go ahead and, like the past example we've been doing, we need to find where our f of x plus h is. So we're going to go ahead and just plug in h into the top, right? Like that. And then down here, we're going to get x plus h plus 1. And notice that these parentheses aren't even necessary. There's no multiplication going on, so we don't have to FOIL anything, so those parentheses are not necessary. It looks much cleaner like that. So going ahead and plugging it into our limit, we have the limit as h goes to 0 of our f of x plus h, so it's x plus h over x plus h plus 1 minus our original function x over x plus 1 over h. You notice that this looks kind of crazy, right? We have a whole bunch of fractions. We have a fraction minus a fraction over something, which is another fraction. What we can do, we can actually pull out this h. We can pull out this h and rewrite it as, because we can rewrite this as this. Because remember that if we have something like if we have two fractions like this, a over b over c minus d, this is the same thing as multiplying by the conjugate, by the reciprocal. Like that. So here we had it all over h, right? H over 1. This is division, so we're going to go ahead and flip this. H over 1 turns to 1 over h and multiply it. And that's just, it's not necessary to do that. It's just going to make our equation look a bit more clean. We don't have that big fraction, so we can just leave this 1 over h to the side. Okay, so now we can't really simplify anything here, not yet, because with fractions we can't subtract unless we have the same denominator, right? This is an x plus h plus 1. This is an x plus 1. So to get common denominators, we're gonna have to multiply both sides by what the denominator is missing, if that makes sense. So over here, this x plus h plus 1, if we multiply this side by a x plus 1 over x plus 1, and then multiply this side by an x plus h plus 1 over x plus h plus 1, the denominators are going to be the same. And I'll show you what that looks like exactly. So up here, I'm going to go ahead and just write x plus 1 times x plus h, right? We're going to have to end up FOILing this, but we'll do that in 1 second. Now this bottom part is x plus 1 times our original denominator, x plus h plus 1. We'll FOIL this stuff in a moment, but let's just go ahead and get our common denominators all settled. So over here on the top we have x plus h plus 1 times x. We'll FOIL that in a moment. And in the bottom we have x plus h plus 1 times x plus 1. Right? Now look, these denominators are the same. Over here we have an x plus 1 times this x plus h plus 1. Over here we have the same thing. So now with fractions, once you have the same denominator, you can combine those two fractions into one. So going over here and doing that, we're going to combine the denominators first, and then we'll combine the top. So it's going to be all over one fraction of just x plus 1, like that, times x plus h plus 1. Sorry, that doesn't look too nice. Like this. What is going on? Like that. And then on the top here, we can go ahead and FOIL some stuff. So here we have x times x, and then x times h, 1 times x, 1 times h. So we're going to get x squared, right? And then we're going to get x times h, right? And then 1 times x, which is just x. And then we get 1 times h, which is just h. And over here, we need to bring that negative sign. And then we're going to put a parenthesis to make sure we don't mess up with our signs. And then here we're going to FOIL in this x to each term. So we're going to get x squared. Then we're going to get plus x or xh. And then we're going to get just plus x. Okay, now we need to go ahead and FOIL this negative like we've been doing. FOIL this negative in to each of these terms. And then so now our new limit is going to be the limit as h goes to 0 of, I'm going to rewrite this whole part right here. And we can't combine anything yet because none of these are like terms. None of them have the same factors. Like this is x squared, this is x and h. So folding in this negative, we get negative x squared. Then we get negative xh, and we get negative x. All over the same denominator. And yes, it's a lot of writing, but sadly, that's how a lot of these limit problems go. But we'll have to get used to it. So now that we fold everything out, we've noticed that in the past examples, once we fold everything, we can start to see some terms that cancel. And so let's go ahead and see if there's any terms that cancel here. So we have an x squared. We also have a negative x squared. Boom. Xh minus xh, 0. X minus x, and then we have an h. We don't have any other h's remaining. So we can go ahead and just rewrite the limit once more. Maybe we'll do it another time. We'll just have h over this denominator right here. But you might be thinking, why don't we FOIL this in? Well, there's no need to. We don't need to. Oh, sorry. The whole time I forgot about that 1 over h. So we need to just bring this along every time. We have this time 1 over h times 1 over h times 1 over h. I'm so sorry about that. So we still have this times 1 over h here. And then look, we don't need to FOIL this in because we can go ahead and do direct substitution once we cancel out these h's that we had this whole time. And then now we should just have the limit as h goes to 0 of just, look, this is just a 1 times 1, the numerator is just 1. Then we have x plus 1 times x plus h plus 1. And then doing direct substitution, plugging in 0 for all the h's, we get 1 over, we just get x plus 1 times x plus 0, because the h is a 0, plus 1. And then this is x plus 1 times x plus 1. This is x plus 1 squared, right? It's the same thing being multiplied to each other. So we're left with 1 over x plus 1 squared. And that is our final answer. This is our f prime. Yes, I know that one was more tricky, but sadly, that's how it's going to go with Calculus 1, just for this beginning part of the calculus class. I promise after this, we won't be having to do any more limits, so that's nice. But yeah, with rational functions is a little bit messy, but I would recommend freshening up on your guys' adding fractions together and getting common denominators, because that's very important, and knowing how to rewrite fractions as multiplication, because that'll be very helpful. It makes everything look much more clean. So let's get on to one more example that'll be very important, and that'll be it for the video. So let's get on to the next one. Okay, so for our next example, we have the function of square root of x plus h. And here we're going to have to utilize a little bit over algebra techniques. And the one that we're going to be using specifically is called the difference of squares. And I'm going to be showing you guys how to use it. But if you're not very familiar with that, I recommend doing some extra research on the side and trying to log down the difference of squares, because that will be very important throughout all your calculus classes. So, like we always start off, right, finding our x plus h, right? And so we just need to plug in x plus h for all of our x's. So we get x plus h, turn that whole thing to x plus h plus 8. So now plugging this into our limit, we have the limit as h goes to 0 of our square root of x plus h plus 8 minus our original function, so square root of x plus 8 all over h. And so the nasty part here is that we have a whole bunch of square roots. And square roots, they don't combine nicely, especially if we have a subtraction in between. We can't really combine these. But what we can do is that we can recognize this as a difference of squares. So if we look here, that since this is being separated by subtraction, we call this a difference, right? So we're going to go ahead and call this whole thing right here our a. And we're going to call this whole thing right here our b. And since we have a subtraction between, we're going to call this a minus b. And so the difference of squares formula says that if we have something in the form of a minus b times a plus b, we can rewrite that as a squared minus b squared. And this is helpful because our a and our b have square roots in them. And like we know that the inverse of a square root is squared. If we have a square root and we square that, it just turns into, these cancel out. So if it's x, square root of x squared, it just turns to x. And so our a and our b here have square roots. So if we square them like this, the square roots will go away. And hopefully we can combine the stuff that's in the inside. So if we recognize this whole thing right here as our a minus b, we can figure out what our a plus b and multiply this whole top part and the bottom part by it. And hopefully we can cancel some stuff out. So multiplying this whole top, the denominator and the numerator, by the conjugate, it's called the conjugate, by our a plus b, just switching the signs in the middle, that's going to be square root of, I'm going to make this a little bigger. So we have x plus h plus 8. And then since this is a minus, we need to make this one a plus, square root of x plus 8. And we also have to do that with the denominator, because whenever we multiply by something, we always have to do it to the top and the bottom to make sure it stays an equivalent statement. So this is basically a giant 1, right? We can always cancel these out if we really wanted to. And so now, look, we have an a plus b. So we have a minus b times a plus b. This is going to turn into a squared minus b squared. So now we can go ahead and rewrite our limit as, so instead of foiling all this out, that would not be very fun. We can go ahead and just rewrite it as a squared minus b squared. So let's identify it to the side real quick. What is our a? So our a is this whole square root right here. So square root x plus h plus 8. And then it's going to go ahead and do this minus, and then minus our b, which was x plus 8. And notice that if we were to square both of these terms, this and this would cancel, and this would cancel, right? This is our a squared minus our b squared, like I said. So now that we squared them, the square roots go away, and now we're just left with x plus h plus 8, with this minus in the middle of just x plus 8. And now we don't have any square roots on the numerator, which is nice. Now we can maybe combine like terms, combine some stuff here. So going back to our original function, rewriting this whole numerator, our original equation, sorry, rewriting this whole numerator as this, our a squared minus our b squared. We're going to get x plus h. We don't need parentheses here. We have x plus h plus 8. And then foiling this negative in, we get negative x and then minus 8. All over h, but we still have this bottom part. It's being multiplied, so it's h times this whole thing. So we have the square root of x plus h plus 8 plus the square root of x plus 8. And so now, this numerator, we can cancel some stuff out, like we have a common term of x and 8. And so all we're left with here is the limit as h approaches 0 of just h all over h times the square root of x plus h plus 8, plus the square root of x plus 8. And here, look, we have a common term, h and h. Like we did earlier, we cancel them out because there's multiplication going on right here. This is not all one term, this is separate. We can multiply. Well, since this is all one term, we can cancel some stuff out. And now, all we're left with is just the limit as h goes to 0 of just 1 over square root of x plus h plus 8 plus the square root of x plus h. And now we can go ahead and just do direct substitution, plugging in the 0 for all the h's. and we just get 1 over, if we just plug in 0 here, we'll just be left with square root of x plus 8 plus the square root of x. I'm sorry, let's take this back 1 second. This is not that. This is x plus 8. Only the square root of x plus 8. Right? Now look, these are the same terms, x plus 8, x plus 8. Since these are the same, we're adding them. This is going to turn into 1 over 2 square roots of x plus 8. Right? Does that make sense? These are the same terms, so we can combine like terms, and we have 2 of them now. Right? Multiplication is just repeated addition. So yeah, this is our final answer. This is the derivative of the function square root of x plus 8. We get 1 over 2 times the square root of x plus 8. And that was a bit more of a tricky one. I really recommend locking in this formula right here. The difference of squares. This is very important. It's not too complicated. And yeah, I really hope you guys enjoyed this video. I wish you guys all the best of luck on your upcoming exams. I really hope this helped. Make sure to subscribe, follow. I'm going to be making an Instagram page for my tutoring. And I also have a TikTok page already that I'm going to link down below, like always. And so yeah, stay updated. Good luck, everyone. Have a good day. Over 2 more examples. I'm going to be showcasing a little bit more difficult ones so you can be prepared for your tests and your homework. So let's get right on to the next one.